Good morning. In the last class we had discussed radioactivity. That is, radioactivity is the process in which unstable nuclei decay into lighter nuclei with the emission of alpha, beta or gamma rays. Now, in this session we are going to study in detail the different radioactive decay modes. So today our topic of discussion is radioactive decay modes. From the picture you can see that there is an atomic nucleus, and from this atomic nucleus either a alpha particle, that is a helium nuclei, He2 that means 2 protons and 2 neutrons. So 2 positively charged protons and 2 neutrons showing an alpha particle is emitted, or a beta particle. Beta particle is, we often say beta particle as electron. Positron also is there, but we will say it beta particle as electron. So electron having a negative charge, so one negative electron is emitted, or there is an emission of gamma ray, which is an electromagnetic radiation. So this process is known as radioactivity, and we are going to study in detail about the different radioactive decay modes. So first one is alpha decay. Alpha decay, you know that it is a process of emission of alpha particle. Now what is an alpha particle? A helium nucleus, that is having atomic number 2 and mass number 4, denoted by He2. So during this process, what happens to the parent nuclei? This parent nuclei will change into another nuclei, which we can call it as a daughter nuclei, in which the mass number of the nuclei will decrease by 4 and the atomic number will decrease by 2. So XAZ, which represents a parent element, will undergo alpha decay so that a helium particle is emitted, that is He2 is emitted, so that its atomic number is decreased by 2 and mass number is decreased by 4. So we will get a new nuclei, daughter nuclei, with the symbol YZ-2 A-4. For example, plutonium with the Z-94 and A239 will undergo alpha decay. That means He2 alpha particle is emitted so that the mass number is decreased by 4. So 239 becomes 235 and the atomic number 94 is decreased by 2, that is 92. So the atomic number got changed. So the element is changed to uranium. You can see that there is a time given which shows the process, time of process, that is 24,000 years, which we can say it as a half-life, and we will study about half-life later. So this is an example for alpha decay. Now beta decay. We know that in beta decay there is an emission of beta particles. Beta particles means either electron or positron. Let's consider electron as the emitted particle here. So the parent element is having symbol XAZ, will undergo beta decay so that an electron is emitted. See, in addition to electron, an antineutrino is also emitted in beta decay process in order to conserve energy, momentum in this process. So you just have to know that along with electron, an antineutrino is also emitted. Now we are interested in the daughter nuclei. What happens to the daughter nuclei? So an electron is emitted and an antineutrino is also emitted. Now what happens to the daughter nuclei? The atomic number is increased by 1. You can see Z plus 1 for Y and the mass number remains the same. So during this process, the mass number of the nuclei does not change but increases the atomic number by 1. Now how this atomic number is increased? So let's have a look on the next slide. See, here you can see a proton is converting into a neutron and a positron plus neutrino. So inside this nucleus, what happens is that this neutron in the parent element is converting into a proton and an electron and an antineutrino, so that the electron and antineutrino is emitted. That means, I repeat, a proton in the parent a neutron in the parent nuclei is converted into a proton, an electron and an antineutrino, and this electron and antineutrino is emitted. Now what happened? A proton is increased. See, neutron is converted to proton, so there is no change in mass number. When a mass number decreased, as neutron is converted, the proton is produced. So that means mass number remains the same. But there is a new proton. That means the atomic number increased by 1. So you have to write a neutron is converted into a proton, electron and an antineutrino. So that since a neutron is converted into proton, the mass number remains the same. But there is a production of new proton, so that the atomic number increases by 1. That's why Z has increased to Z plus 1 and A remains the same. So this is an example where you can see that carbon C614 is converted into nitrogen with atomic number 7 and mass number the same, that is 14, plus electron. You can write an antineutrino with the electron on the right side. Now what is gamma decay? Gamma decay is the process of emission of gamma rays. And during this process, there is no change in atomic number and no change in mass number of the nuclei. See, what happens is that after the emission of alpha or beta particle, the nuclei will remain in excited state. So, in order to come back to its ground state, excited state means the nucleus is having higher energy. Even after emitting alpha or beta particle, the nucleus will be still in excited state condition. So, it has to dissipate its extra energy. So it dissipates its extra energy in the form of gamma ray. So after the emission of alpha or beta particles, the nuclei will result in an excited state. So these nuclei will return to the stable ground state by the emission of gamma rays. So here you can see a parent nuclei which is in an excited state given by XAZ. It emits a gamma ray. So gamma ray is given with value 0 and 0. That means no charge, with the daughter nuclei as XAZ itself. So another picture showing that the parent nuclei is in the excited state and it undergo gamma decay, so that a high energy gamma ray is released and the nuclei will be in its stable ground state. So here is what we had studied, that is alpha decay, in which XAZ is converted to X dash Z minus 2 A minus 4 by emitting an alpha particle, and by emitting a beta particle, that means the neutron is converted into a proton, electron and an antineutrino, so that atomic number increases by 1 and mass number remains the same. And in the case of gamma emission, you have to note that the parent nuclei is in an excited state, and that excited state undergo gamma decay and results in an stable state. And the excited state can be shown with a star on the top. So you can write a star on the top of the X in the left hand side in order to denote that nuclei to be in excited state. Now the next decay mode is electron capture. Electron capture is the opposite of beta emission. So what is beta emission? Emission of electrons. Its opposite means this electron is being captured by the nucleus. So electron capture, by the word itself, means that the nucleus captures an electron. Now from which shell the nucleus will capture the electron? From the nearest shell, isn't it? So which is the shell nearest to the nucleus? It will be the first orbit that represents the K shell. So the nucleus will capture an electron from the K shell when it consists of rich number of protons. So when the nucleus, excited nucleus, there is an important thing to remember, the nucleus is in an excited state. So when the excited nucleus is having high number of protons, due to the presence of these protons, the nucleus will attract an electron from the nearest K shell, and this process is known as electron capture or K capture. So what happens to the K shell? There will be a vacancy of electron in the K shell, isn't it? So that vacancy is filled by another electron from higher orbits. So that electron is coming from higher to lower. So they will emit radiations, and that radiations are known as X-rays. I repeat, when the excited nuclei is proton rich, it returns to the stable nuclei by capturing the electron from the K shell, and this process is known as electron capture or K capture. The vacancy caused in the K shell is filled by the movement of electron from the higher orbit. So the electron from the higher orbit is transferred to the K shell. So what happens? There is an emission of energy, and that emission is in the form of X-rays. So how we can write the equation? XAZ. It is a parent nuclei. You can put a star there in order to represent that nuclei to be in an excited state. So XAZ star plus electron giving you another nuclei Y with Z minus 1 and A. Now how Z becomes Z minus 1? We know that this parent nuclei is having more proton, isn't it? So whenever this nuclei absorbs an electron, this proton and electron will combine together to form a neutron. So a proton is converted to neutron by capturing an electron. So there is no change in mass number. Since a proton is converted into neutron, there is no change in mass number, but the proton absorbs an electron and changes to neutron. That means Z is decreased by Z minus 1. So you can write the equation as proton plus electron will be giving a neutron and a neutrino. We are not concerned with the neutrinos. We just have to know how the proton becomes a neutron. Proton on capturing an electron becomes a neutron. So proton is converted to neutron. That means there is no change in mass number. But what happens if a proton got decreased? So Z becomes Z minus 1 in electron capture. An example is there, carbon 11 having 6 protons and 5 neutrons absorbs an electron. So what happens? The proton and electron, proton from carbon 11 combine with electrons, so that there will be a decrease of proton, that is 5 protons, and a new neutron is formed. So 5 neutrons becomes 6 neutrons. So 5 protons and 6 neutrons, again the mass number remains the same. So carbon 11 will become boron 11 plus an emission of a neutrino. And the last type of decay mode is positron emission, in which we had already studied about positron emission in beta decay, that is emission of a positively charged electron called positron. So positron is like an electron, but it is having opposite charge, that is positive charge. Now what happens in a positron emission? This element XAZ will emit a positron and will become a new daughter nuclei Y with the same mass number, but the atomic number decreases by 1. How? H11, it denotes the proton. So a proton is converting into a neutron and a positron with the neutrino. So proton is converted into neutron, positron and neutrino. So this parent nuclei XAZ, in the parent nuclei a proton is converted into neutron, positron and neutrino. This positron is emitted as well as the neutrino also is emitted. Now the proton is converted into neutron means there is a proton got decreased and a neutron got produced. So there is no change in mass number. Now the proton is changed to neutron means atomic number decreases by 1. So Z becomes Z minus 1. Example, thorium 90-232 becomes, Z decreases by 1 means it will become 89. So the new element is new daughter nuclei is actinium with the same mass number 232. So these are the different radioactive decay modes in which we had studied the alpha decay, in which the mass number reduces by 4 and atomic number by 2. In beta decay, the atomic number increases by 1 and the mass number remains the same. And in gamma decay, there is no change in atomic number as well as the mass number of the parent nuclei, so that the parent nuclei remains as itself. Then the fourth process was electron capture, in which the atomic number decreases by 1 and mass number remains the same. The last process was positron emission, in which the mass number remains unchanged but the atomic number decreases by 1. I think it's clear to you. For each radioactive decay modes, you have to include the explanation, the equation, general equation followed by an example. Thank you.